Okay, now in this video I'm going to try to explain why bounces occur. So if you watch the last video, I believe it'd be part 3, this is a very similar picture. We have the same y equals x in green, and I have a vertical line drawn there in green. To the left shows where y equals x is negative and below the x-axis, and to the right of that green line is where y equals x is positive. And then in orange and red I show where the red line, y equals x minus 3, is positive above the x-axis versus where it's negative. Now the orange line you can't see because it's identical to the red line. Alright, now the purple graph is a product of all three of those. Notice how it goes through 0, okay, right here, but it bounces off 3. Okay, now to the left of the green line, this purple graph, and I should highlight it in purple, is negative, and you could have figured that out just by looking at these three factors here. Alright, because it's a negative times a negative times a negative on that interval where x is going to be less than 0, which is why this graph ultimately is going to be below the x-axis, and it's going to have that end behavior. Now when x is 0, it crosses the x-axis because 0 times anything is 0. Now on this interval, the graph is going to be positive, because on that interval, all right, the green graph is positive, but the red and orange graph are negative. All right, a positive times a negative is a positive. So on this interval, the graph is going to be above the x-axis. Now, when x is equal to 3, it hits the x-axis. Y is equal to 0. All right, so there's an x-intercept there. Now, to the right of that red line, it doesn't change. It's going to stay above the x-axis. Now, the red graph changes sign. It goes from being negative to positive when x becomes greater than 3. But the orange graph is the same exact line, so it also changes. So just like this double negative multiplied together gave us a positive, and then times a positive is still positive, a double positive is also positive. So that's what a bounce is. A bounce is showing that it's not going to change sign at that x coordinate, at that 0. Alright, oftentimes it will, because if one of the factors sign changes, it'll change the sign of the entire function. Right? When x changes sign from negative to positive, y equals x times x minus 3 changes sign from negative to positive. But because of the double 0, alright, when y equals x minus 3 changes sign from negative to positive, they kind of cancel each other out, so it doesn't change sign, hence that's why there's a bounce. Alright, and this same thing would occur if you were to change this to a 4 or an 8 or a 6. So for any even power, there's going to be a bounce. Now, if I were to change this to a 3, alright, there's going to be what's called a snake. Alright, so a snake, if you look to where x crosses 0, it's regular behavior. It goes right through the 0. But if you look at where x equals 3, it snakes through it. And that's not really a math term, but that's what, we describe it here. And it's kind of just like a flattening out around the 0. Alright, now let's look at why that happens. Okay, to explain why that happens, I graphed, oops, I lied. Alright, now I didn't lie. I graphed y equals x and y equals x minus 3. Alright, so these two graphs have a lot in common. They both have the same end behavior, they both have the same 0. But they also look very different. They don't have everything in common. Alright, between 0 and 1, I want you to notice how the purple graph is below the green graph. And then when x equals 1, they are the same point. And then when x is greater than 1, the purple graph is above the green graph. Alright, now if we look at why the purple graph is above the green graph after 1, that's because when x is greater than 1, when you cube it, it's going to be greater than what you cubed. So if we look at when x equals 2, okay, 2 cubed is equal to 8. That's why it's above this point here, 2 comma 2, because if you cube 2, it's going to get bigger than if you just don't do anything to 2. Now if you cube 1, it's going to be the same as if you didn't do anything to 1. That's why they share this point. But if you think of what happens to numbers when they are less than 1 but greater than 0, alright, let's take 0.5 for example. If you were to take a half of a half of a half, you're going to get a number less than 1/2, which is why it's below the line here. So the reason why this snake occurs is because when you have numbers in between 0 or 1, or even between 0 and negative 1, alright, they're going to get closer to 0 when you raise their power. So if you were to take 1/2 and square it, it's going to get closer to 0 than if you didn't do anything to 1/2. But if you cube 1/2, it's going to get closer to 0 than if you squared it. And if you raise 1/2 to the 4th power, that's 1/16. That's closer to 0 than if you cubed it. So that's why it has this behavior. And it kind of also applies to like x squared versus x to the 4th. Alright, notice how in between 0 and 1, x to the 4th is closer to 0 than when it's greater than 1. Alright, but if I make this to the 6th, alright, now the green graph is below the blue graph, because when you raise numbers that are in between 0 and 1 to the 6th power, alright, they're going to be closer than 0 than if you raise it to the 4th power. Okay?